I would like to welcome everyone to the FuzzCon Europe 2020. It's really great to see that many people connected here. We had over 1,000 registrations this year, and right now there are about 500 people connected at the same time. Yeah, and this wouldn't be possible without the great lineup. So a big thanks to all the speakers. Yeah, and obviously thank you to the participants and especially my team. Without you, it wouldn't be possible to host this event. Actually, it's our second time hosting this event, and it all started with the idea on a meetup in Bonn with 20 people, where we thought, okay, let's bring the research and industry people together to share some ideas how to test software. And this is how our first conference was born. What's all the fuss about last year? So basically the FuzzCon Europe 2019. And there were about 60 people there back then. And this year we wanted to double the size. And then due to COVID-19, this year the conference couldn't happen on site. That's why we decided to host this conference online. And we were really happy when we have seen that there are 1,000 registrations, and this also sets really high expectations for the next year. Based on the personas who is participating on this event, there are about 150 registrations from research, but even more people from the industry, and it's a mix of people who are using fuzzing for years with people who are newbies and want to use fuzzing soon. Yeah, so who am I? I'm Sergej, CEO and co-founder of Code Intelligence, and I have a usable security background. Usable security is a research field where you tell security researchers that their products are not usable, the same way as security research tell developers that their products are not secure. And with that background, we decided to found Code Intelligence with two co-founders, Henning and Khaled. You will see them later in this event. And our mission is to enable companies to bring their software testing to the next level. And obviously, fuzzing is a kind of big part in that. And what we want to do is basically to assist companies to build great, secure, and robust products. And I mean, this is exactly what drives Code Intelligence. Almost every product nowadays has a little piece of software in it. And we are convinced that fuzzing is a fundamental part to get the software stable and robust. So since we started with the fuzzing project with Code Intelligence in 2018, the three co-founders, the team grew a little bit. Nowadays, we are 16 people. Okay, and when we started in the beginning 2 years ago, we were approaching companies and asked them whether they use fuzzing, and we noticed that at that time no one even knew AFL, even though it produced one of the best results in finding security issues, but also stability issues automatically. And this changed immensely over the last 2 years. Right now, when we come to companies and talk about fuzzing, it's totally different. Right now, companies are ready to use it, and everyone kind of heard that fuzzing is a kind of hype right now. And our mission today with this event is basically bringing fuzzing experts together with industry representatives to get exclusive insights with this emerging tech. And when we had a questionnaire in the beginning to the registration, we noticed that a large group of participants hasn't used fuzzing yet or is still learning about that. And to avoid that every talk today starts with a fuzzing introduction, what is coverage-based fuzzing, we decided that we do it once in the beginning in this talk, and then everyone just doesn't need to start from scratch. So let's start with the intro. I mean, most of the people today are probably old enough to know how security testing was done in the past. either it was not done at all, or there were security and testing experts who kind of have done the testing manually, either with code reviews or writing some specific queries attacking the applications. And I mean, with this manual code reviews, since smart people are analyzing the code, this finds a lot of bugs deep in the code. But as you know, good people are rare, and every company kind of has issues in hiring new good people. And that's why this had to be done in a more scalable way. And this is how static and dynamic analysis were born. Basically, with the static analysis, as the researchers the security people started to grab for common pitfalls, and then it got more complicated with control flow graphs, data dependency graphs, and so on. It evolved into a really huge industry of the static code analysis. And in parallel, there was a dynamic analysis where you basically tried to attack the application with inputs. And here the question is how to give inputs so that the application crashes once it runs. And it has the advantage to static code analysis that this way you get far less false positives, and you kind of always get the input which leads to the crash. And fuzzing is one of the dynamic techniques here. And just a little background, obviously it started in the academia. And there is always this cliche that if you ask a professor what's the next big thing to do automatic software testing, they would say, oh, it's an almost solved problem, fuzzing and symbolic code execution, you should use it. But on the other hand, there is this cliche that no one is using what the security researchers are telling. But with fuzzing, it's totally different. If we look at the success story of the big industry leaders such as Google, they themselves claim that they find most of the bugs with fuzzing and started several initiatives how to test or fuzz code automatically. And I mean, if you just look on how many CVEs have been found with AFL, and the success story of OSS Fuzz, where it found on about 20,000 bugs in 16,000 bugs in other really important open source projects such as OpenSSL, and even 12,000 bugs on Linux, where people start to complain, oh, it finds too many bugs here. And I mean, there are other players. Microsoft is also using a lot of fuzzing and symbolic code execution with Sage. And in 2 weeks at the CPPCon, they will present their own open source framework, how to do fuzzing. And there are other examples like Mozilla Firefox and a lot of industry leaders who don't publish their numbers. So for the people who don't know too many details of fuzzing, just a small reminder or a little history how fuzzing evolved. It all started with random testing back then. Basically, back then, the inputs were given by punching cards. And what the people started is that they took some random punch cards from the bin and ran those through their application. And the goal was basically to make sure that nothing crashes. And basically, if there is a punch card which leads to a crash of the system, then you found a bug and could fix it. So later, it got a name. It was not just random testing anymore. It got the name fuzzing, coming from research. And the goal here is basically that the fuzzer is producing some random inputs, gives those random inputs to a system under test. If the system under test is crashing, for instance, by having a segmentation fault or buffer overflow, then you found a security issue and would basically fix that issue. So to make a visual example, if we want to test an image parser, something like a JPEG parser, then obviously it's very unlikely to produce random inputs, which will be a valid JPEG. And that's why most of the bugs back then were in the beginning of the code, basically taking care whether it's a valid JPEG or not. So in the 90s, people came up with new ideas, somehow combined the randomness with some existing tests. And here we could start with some images, give those to the image parser, and then start to randomly mutate some bits and bytes inside that JPEG so that we get a lot of valid JPEGs, but they are quite similar to the original input. And we would get invalid JPEGs, but getting deeper inside the code. Obviously, in this technique, we have to take care a lot of the examples and still might not know what is happening inside the program. And I mean, and this was around 2014 when AFL basically started a renaissance of fuzzing. There was basically a new wave of fuzzing research where instrumentation has started to be used. And instrumentation is something like you get additional markers in the code, and the additional markers in this image parser would kind of tell an AI or the fuzzing engine what is happening inside the program, so that we stop doing it completely random, but could find patterns or predict some inputs. So basically, we won't start completely without examples with a 0, which is a JPEG which cannot be shown. And at some point, when we run those inputs where we mutate some random bits and bytes, it gives feedback to the mutation engine, what is happening inside the program. Basically, what path has been taken, what kind of strings or bytes have been compared, and so on. And then the fuzzing engine, since it knows what kind of numbers or what kind of inputs are in different paths, knows a lot more and can this way maximize the code coverage more efficiently. So let's say every JPEG starts with some magic bytes. So definitely inside the instrumentation, you will see a lot of string comparisons with those bytes. And so we start with the 0, see that inside the application there is a comparison with some magic byte sequence. We will produce this byte sequence in the next run. We'll see that it gets in a new basic block, and this way we start making new deviations from that input. So basically, the next thing could look like that, or we change some more colors. And this happens all the time. So basically, several thousand times per second. You could also give some examples to that. Then it will get faster because you are not starting from 0. And this way, AFL created a kind of renaissance of fuzzing. Obviously, in fuzzing, this is a very oversimplified version of what is actually happening in the fuzzing, because there are also a lot of instrumentation things which take care of memory safety and to know what kind of thing caused the bug. For instance, address sanitizers in C++, or some specific instrumentation in Java where you know whether database queries are triggered or not. So, but coming back to the conference, what should we expect from the FuzzCon Europe today? And basically, we have two types of talks today from researchers, but also from the industry, where they present their ideas or their challenges they kind of solve. And we will start with the human aspects. So basically, there will be talks which focus on the people who are working with fuzzing, because now we need to get developers on board, and developers are sometimes lazy to write unit tests. Why should they use fuzzing? And also now there is a software which claims that they made mistakes, and the developers have to kind of accept that. There is also the learning curve. because they use traditional testing. It uses some specific vocabulary, but with fuzzing, the fuzzing researchers introduce new vocabulary, so they kind of have to accept that. And here we have 3 different talks about the human aspect, starting with Matthew Smith, who will talk about the usability issues in modern fuzzing. And then Christian Holler from the Mozilla security team will tell us how they introduced fuzzing within Mozilla and got the developers to accept those results. And then Caroline Lemieux will tell us how to expand the reach of fuzz testing, tackling the human aspects here. And I mean, on the one hand, we have the human aspects, but on the other hand, sometimes there are corporate issues which needs to be solved. And this might be that in some parts of the industry, there may be some outdated commercial compilers which are used, or specific tools in the process which need to be considered inside fuzzing. And here we will have a few talks triggering that. And I mean, one of my favorite examples is that a lot of projects which started like 20 years ago and didn't have any unit tests can only be run as a whole and probably on a specific platform or specific hardware. And here, if we want to do fuzzing, there is a huge gap to introduce it, which definitely has also been solved partially. And here we will have 4 industry experts talking about these issues. So there will be a fireside chat with some representatives from the industry, like Götz Martinek, Tobias Esser, and Alexander Weise, but also Rakshit Amanat from Bosch Corporate Research, who will tell us about the challenges, what makes fuzzing different in automotive software. And in the beginning, we have seen this easy example of a JPEG parser, which is like the perfect issue to do fuzzing with a JPEG. But in a lot of industry applications, things might get more complex, especially when you do a system test like fuzzing. And here again, there are a lot of new concepts how even this can be handled with fuzzing. And for this, we will have 4 different talks for structure awareness and network communication and stateful fuzzing. So starting with Sergej Dechand, who tested an intrusion detection system with fuzzing and found 12 CVEs. Then Cornelius and Sergej, who will tell us about stateful fuzzing with snapshots. And Bhargava Shastri, who will tell us how to fuzz as the Solidity compiler within the Ethereum blockchain. And obviously, no technology will get accepted in the industry without a deep inside that. And here we will have 4 different talks, starting with Marcel Böhme, who will reflect about the challenges and reflections in the fuzzing area, coming to Andreas Zeller, who will tell us how he wants to tame the fuzzers. And Sebastian Pöblau will tell us how to maximize code coverage by using, in addition to fuzzing, additional techniques such as symbolic code execution and what he achieved with his research. And ending with Kostya, who will present us the top-end challenges of deep fuzzing. And yeah, also most of the talks focus a lot on fuzzing of C and C++ applications, because C and C++ are the best languages to shoot yourself in the foot. However, the same techniques can be used in the industry, and also there are even more applications in the industry which are using fuzzing. For instance, if you have a look on which kind of applications are starting right now, most of the applications have a kind of web backend offering a REST and URL encoding and SOAP interfaces, sometimes protobuf, and this web service is then offered to the internet, and then you connect via a user interface on the web browser or mobile applications to that web applications, and showing that this is like the most crucial part in companies to secure with. And I mean, there you typically use languages which are memory safe, so you wouldn't search for buffer overflows or memory issues, but instead there are OWASP applications. And I mean, there are OWASP, top 10 is as the most prominent example. And here there are a lot of very, very good pen testing approaches where you do black box fuzzing, but compared to the results you already get with C and C++, this kind of is a little behind. And coverage-based fuzzing for Java just started recently, and there are the first open source projects. But Sergej Dechand from Code Intelligence will present today how he the Code Intelligence fuzzing platform is handling those kind of OWASP issues as well and maximizes the code coverage. And today's event will be ended with an open Q&A session where you are able to ask the experts. And you probably wonder, what is Code Intelligence doing with fuzzing? So basically, we create a fuzzing platform which can be used to in the industry, and our goal is to make fuzz testing easier for companies. And there are already a lot of companies which are using our product. And the goal of the FuzzCon today is that we want to show the progress in fuzzing for the industry. And my personal vision is kind of that in future, no software should be delivered where bugs could have been found with fuzzing or any other automation technique. And to conclude the opening of the FuzzCon, I mean, a lot of people are already saying that fuzzing is the superior technique to find a lot of bugs in a scalable manner. And it even already has a huge traction in practice. And today we will hear a lot of talks from fuzzing experts, how they tackle the challenges in the industry. So thank you, and I'm open to questions.